Hi, my name is Christine G, and we're going to be taking a look at Module 3, specifically the assignments. And we can just scroll where here I am in the learning modules, and you can just scroll down here and click on Module 3, and you'll have the usual activities in ZBooks with the participation activities, challenge activities, and then here we have the Module 3 assignment, and again, it's on real estate analysis, and this is part 2. And when you go to submit your assignment, you're going to click into this to submit it. And then here it are the requirements and the instructions. So we're going to go in there and take a look at it. And this is just going to be a couple of tips for you, nothing major. We're not going to go through the whole assignment. So here you have the real estate county data spreadsheet. That's the same one from assignment 1, and so you'll download that, and then a document with the national statistics and graphs. And then you want to make sure you're using the Module 3 assignment template. That, I think I've downloaded it. Yeah. So here you have the different sections. You're going to be substituting in your name and just the different sections that you're going to be doing. So determine R, and this is the correlation coefficient. So we're going to be looking at that and examine the slope and intercepts, but you want to make sure that you're filling in this information. However, you also want to make sure that each of these parts are answered and that you're completing everything to be exemplary as far as the rubric goes, so that you can get full credit. So you want to, this is a way to double check things, looking at your rubric and making sure each part is answered properly. And what we're going to take a look at is the data, and let me go ahead. So this is not the data that you will be using. This is not real estate data. So percent of calories from animal protein, and then the heart disease rate per 100,000 men between 55 and 59. So um, this is the explanatory variable, and this is also called the X variable, and then this so would explain the relationship and give the predicted values. So what we're going to do is look at the this and do a regression analysis. Now, um, if you do not have this information in here, so I go to the data analysis tab in Excel, and it's got to be Excel on your desktop, not the one online. And if you don't have it, write to me, or in the announcements, you'll be able to find a video that I did on it as well as some instructions. So here, the regression, you want to select that, and then we're going to click OK. And then you're going to input your Y range. So it's this column, and that's the predicted value. And then we're going to do the X range. So this is the explanatory variable. And then you'll notice here it says new worksheet. And that's where our output is going to be. We could do it in the regular sheet that has all the data, or we could do it in a new sheet. So why don't we, usually I just do it in a new worksheet, but we can go ahead and for the purpose of the video, do an output range here. And let's just put it, we don't want it to go over any of our stuff. And then let's see if that works. Hopefully we gave it enough room. Yes. Okay. So, and if you don't have it in this output range, then it will just automatically create a new sheet, which is fine too. So, here multiple R. Now, this is the sample correlation coefficient. So that's, we're going to, in the instruction, it refers to a lowercase r. So that is what we're referring to because we just did a sample. We didn't do the population. So this isn't for everybody in the world. So um, anyway, the correlation coefficient can see is quite high. And correlation coefficients go between -1 and +1. So the lowest it would be 0, which would mean that there's no association or relationship. And so this is very close to 1, and anything very close to 1 or -1 would have a strong correlation. Now, a word of caution, this number is positive, but we have to consider the estimate of the x variable, which is actually the slope estimate. So here, this is also positive. If this was negative, then that would mean the slope is going downhill, and that would mean the correlation, even though it's strong, would be a negative. So this is definitely a strong positive. So that what that means is that as I increase calories from animal protein, as this increases, the it's increasing, the pattern overall is increasing the heart disease rate. So anything 80 and above, or this is 80% or and above, or well, we should look at it as anything zero point 0.8 and above, all the way up to 1. That's the highest it can be. And then the lowest it can be is -1. And -1 would be all the points are on that line going downhill. And so here, now R square, this is just taking this particular number and squaring it. So this tells us the variation that is created between from the explanatory variable and the variation for the y variable. This number can only be positive because when you square something, you're taking that number and multiplying it by itself. So even if it was a negative number, a negative times a negative is positive. So this is also something that you want to look at. And then here, in order to set up the regression equation, that we can do, I don't want to mess up the data, but I do want to make a cell that's like bigger. So let me go ahead and do that. There we go. So I can set up my sample. This is a sample of a simple linear regression. So this would be y hat, and I'm not going to write y hat in there here though, because this is sample, but I'll just write it as y because it's trickier for me to write it as y hat in Excel. So then I take my slope, which is this amount, and I'll just round to 2 decimal places, which would be 80.90. And then times x, that's my slope. So as the percent of calories increases from animal protein, so does as it increases by 1 percentage point, this would go up by the number of the heart disease death rate would go up by 80.80. And then our slope intercept estimate is -142.51. There we go. So this is our equation for our regression. So our sample's a linear regression. And then if I wanted to calculate if if the percent of animal protein goes up by, let's say, or if it is at, not if it goes up by, but if it is, let's say, 9%. So what I can do is I can just calculate that in Excel, and all I'll do is put in 9 for X. So I just say 80.80 times, and instead of writing X, I'm substituting in 9 because I want to see what the death rate would be, the heart disease death rate would be if 9% of the calorie intake is from animal protein. Okay, so the only thing I replaced was X, and I just put in 9. And then the death rate per 100,000 people, 50 males 55 to 59 would be 584.69. So that's it for now. But if you have any questions, feel free to reach out to me anytime, and I am always here to help you be successful. So thanks so much for watching, and have a great day.